Hello everyone, today we're going to be going over the June 2025 Algebra 1 Regents exam. In this video, we're going to be focusing on parts 2, 3, and 4, or in other words, we're going to be going over the entire short response section of this exam. A link to this test can be found in the description of this video if you want to follow along at home, alongside another video that goes over the entire multiple choice section of this exam if you want a full review of it. That being said, we're going to go ahead and start off with number 25, which says that a survey was taken to determine whether students prefer to watch videos or listen to music. Of 100 students surveyed, 44 were seniors. Of the 65 who preferred to watch videos, 42 were juniors, and we need to use this information to fill out the frequency table. So whenever you do a problem like this, I want you to familiarize yourself with one phrase. That's of. When you say of the blank, that means you're talking about the total specifically, right? So of the 100 students surveyed, if you're surveyed, that means that you were asked the question, okay? And students were surveyed here and the results were shown here. So of the 100 students surveyed means that there's 100 students in total that they asked questions, right? Because it's of those surveyed, okay? So of the 100 surveyed means out of all 100 kids that were asked questions, 44 were seniors. So here we have a total column and here we have a total column. Wherever you see two total columns intersect, that's what we usually call the grand total, or the total of everything, right? So juniors, seniors, watch videos, listen to music, everything in total. Because there's 100 people, so there should be 100 responses. So out of those 100 people, 44 were seniors. So in total here, when we add up the number of seniors that watch videos and listen to music, there should be 44 of them. Then it says, of the 65 who prefer to watch videos. So guess what? There has to be 65 students who prefer to watch videos, because of means total. So in total, instead of reading it as of, in total, the 65 students who prefer to watch videos, 42 of them were juniors. So out of this 65 total, 42 of them were juniors, okay? And then that's the end of that information. So from here, I can just do some basic addition. So if I have 65 here, that means that there have to be 35 students in total who listen to music, because 65 plus 35 is 100. Then over here, if 42 watch videos and X are seniors, 42 plus X is equal to 65. So what does that number have to be? That number obviously has to be 23, right? And then 23 plus what is equal to 44? Well, it's 21, okay? And then finally, if I want 44 plus what is equal to 100? Well, that's going to be 44 plus 56, right? And finally, 42 plus what is equal to 56? Well, that's 14. Okay, so this is the entire table filled out. You don't need to show work here. That's all you needed to do. Okay, so once you just plugged in those values, the rest of it is just seeing if it all adds up together. So as long as all these columns and rows all add up together, then you're going to be good. You'll get this question fully correct. Okay, so just remember, of the blank means total. Okay, we're considering that as our total. So number 26 asks us to solve the inequality for y. So we just treat this as any equation, right? Pretend like this greater than sign is an equal sign, doesn't really matter. So the way I want to do this is I want to combine like terms. So I'm going to multiply or expand this 5 out. So here I have 5 times 2, which is 10, and 5 times negative y, which is negative 5y. Why did I do that? Well, I want to get it out of the parentheses so that I can actually begin to combine like terms and then solve for y. So here I have 10 minus 5y is greater than negative 11y minus 8. So from here I'm going to add 11y to both sides. I'm going to add 11y to both sides. And I have 10 plus 6y is greater than negative 8. So from here I can subtract 10 from both sides, and I get that 6y is greater than negative 8 minus 10, which is actually negative 18. This is greater than negative 18. And then finally, I want to solve for y, not 6y. So I could divide both sides by 6, and I get that y is greater than negative 3. And that's going to be my correct answer here. All right, moving on. Number 27 asks us to express 5x minus 3 times negative 2x plus 7 as a trinomial in standard form. What is a trinomial? Well, a trinomial is like ax squared plus bx plus c. All right, there's 3 numbers there, hence trinomial. Nomial means number, tri means 3. So we need to express this as a trinomial. In other words, just multiply it out. That's all you have to do here. Multiply it out and combine like terms. So what you're going to have to do here is multiply 5x by negative 2x. That gives you negative 10x squared. Here we have 5x plus 7, which is positive 35x. Here we have negative 3 times negative 2x, which is positive 6x. And here we have negative 3 times positive 7, which is negative 21. So combining everything together, we get negative 10x squared plus 41x minus 21. And this is a trinomial because guess what? I have 1, 2, 3 numbers, or 3 terms. And that's it. And when they talk about standard form, just make sure that your exponents, the biggest exponent is in the front and the smallest exponent is in the back. So the biggest exponent here is x squared followed by x to the power of 1. So x squared, x to the power of 1, and technically this is x to the power of 0, but we don't talk about that. Just remember that the number without the x is always last, okay? So it should be in decreasing order of exponent, like so. All right, so number 28 says the first and fourth terms in an arithmetic sequence are given below, okay? So we have negative 20, then an unknown term, then another unknown term, then negative 2. And they want us to determine the 8th term. So here's the thing. An arithmetic sequence is just a list of numbers that are related by a certain rule. So for example, 2, 4, 6, 8, 10, that's an arithmetic sequence because they follow a common rule. The rule is to get to the next term, add 2 to the last one. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. Notice here that the amount that you're increasing by doesn't change, and that's what makes an arithmetic sequence an arithmetic sequence. You're increasing by the same amount. So in this case, to get from negative 20 to this mystery number, I increased by an unknown amount. Then to get from this mystery number to the other mystery number, I increased by another mystery amount. And then to get from this mystery number to negative 2, I also increased by a unique amount. All right, but all in all, to go from negative 20 all the way to negative 2, I had to increase by 18, right? I added 18. Now notice here how in this arithmetic sequence, I'm always adding by the same amount. And so that means that in this arithmetic sequence, I'm also adding by the same amount. So when I add this question mark 3 times, in total, it's equal to 18. So in other words, if this is plus x plus x plus x, that means that adding x 3 times, so x plus x plus x, or 3x has to equal to, or has to sum up to, a total change of 18. In this case, x has to equal to 6, okay? So that means that we're increasing by 6 to get to the next number, okay? So here's 6, and here's 6. So to verify this, let's just go ahead and let's see. Negative 20 plus 6 is negative 14. Negative 14 plus 6 is going to be negative 8. And negative 8 plus 6 is negative 2. So that's correct. Now we want to find the 8th term, okay? So what we can do here is we can just extend this list outwards, right? If this is the first, second, third, fourth, then this is the 5th term, the 6th term, the 7th, and this is the 8th term. So negative 2 plus 6 is going to be positive 4. 4 plus 6 is 10. 10 plus 6 is 16. And 16 plus 6 is 22. So the 8th term is going to be 22. That's all we needed to do here. Okay. Number 29 wants us to write an equation in slope-intercept form for the line that passes through the point negative 2, 5 and has a slope of negative 3. Okay. So slope-intercept form, that's y equals mx plus b. Okay. Where m is the slope and b is the y-intercept. All right. So in this case, we know that y equals mx plus b, and we can actually plug in that y is equal to negative 3x plus b. Why is that? Well, we know that the slope is negative 3, so that goes where the m is. Now, we need to solve for b. So how can we solve for b? Well, it's very simple. Just plug in the point that it passes through. So this point is written as x comma y. Okay, so that means that the y has to be 5. So 5 has to equal to negative 3 times our x, which is negative 2, plus our b. So 5 is equal to negative 3 times negative 2, which is positive 6, plus b. That means that b has to equal to negative 1. Okay, so I know my m is negative 3. I know my b is negative 1. So if I combine everything together, I know that y is equal to negative 3x minus 1. Okay, so that's going to be my equation in point slope form, and you did not need to graph this. Okay, so the use of these axes was optional. But let's say that you didn't know how to do the math here. How could you have used this? Well, you understand that slope is rise over run, and when you have a slope of negative 3, that means that your rise is negative 3. So if your rise is negative, that means that you're actually falling. So you're going down by 3, and you're going to the right, or you're running to the right by 1. Okay, so if we pass through the point negative 2, 5, that's negative 2 is here, and then 5 is 1, 2, 3, 4, 5. Okay, let's apply our slope here. Our rise is negative 3, so we're actually falling by 1, 2, 3, and my run, how much I'm going to the right by, is 1. So in this case, boom, that's our second point. We went down by 3 and to the right by 1. Let me quickly fix that. So we went to the right by 1. Okay, so here's our right by 1. Let's do it again. So this is 1, 2, 3, and to the right by 1. Okay, 1, 2, 3, and to the right by 1. And just like this, I've actually graphed out this equation. And without doing any math, I actually see that my y-intercept is negative 1. Right, so this confirms my answer. Remember that the y-intercept is when you cross over the y-axis. It happens only once for a function, okay? So we can see that line I drew passes through the point, negative 1. So that has to be the y-intercept, right? You go down by 3 and you go to the right by 1. You intersect this point. That point is on the y-axis. That's the y-intercept, and that's another way of solving for b without doing all that math, okay? So number 30 asks us to factor out x cubed minus 36x completely. So I just want to figure out what these terms have in common. So I know that x cubed is the same thing as saying x times x times x. And I know that 36 is the same, or 36x is the same thing as saying 36 times x. So by writing this out, it's pretty simple what we can take out. We can actually take out an x from both terms. So if I take out an x, that means I'm writing it outside the parentheses. And what's left is x squared minus 36. Remember, this is a 36x, but we're subtracting it, so the minus sign still stays here. Now, you might be thinking that this is your answer. That's actually false, right? Because this is a difference of perfect squares. Remember that a squared minus b squared is equal to a plus b times a minus b, okay? So in this case, x is a and 6 is b, because 6 squared is equal to 36 and x squared is equal to x squared. So now we just write x times x plus 6 times x minus 6. And now this is fully factored. So guaranteed on your Regents they'll ask you about a squared minus b squared. Please, please, please remember this, right? Don't leave two perfect squares that are being subtracted from one another alone. Split them up into those two parentheses, okay? All right, part 3, it says graph f of x is equal to negative 3x and g of x is equal to x squared plus 2 on the set of axes below. So what we can do here is we can go into our calculator and plot these 2 points out. So here we have negative 3x, and over here we have x squared plus 2. So here we have x squared plus 2. All right, now when we hit graph, we can get a table view of all the points. For f of x is equal to negative 3, you only need 2 points. And then you, with your straight edge ruler, you can just draw a line through those 2 points because it's a linear equation. So for this line, we know that it passes through the point 0, 0, the origin, and then it goes 1, negative 3. So 1, negative 3, so 1, 2, 3. Then it goes 2, negative 6, so 1, 2, 3. 2, negative 6. Then it continues to decrease like so, right? And then in the opposite direction, it goes the opposite way. So when you connect all these points together, you get this straight line that looks something like this. My line isn't straight, but on the Regents, you will have a straight edge ruler. Make sure to draw arrows at the ends of your line, and make sure to label your line so that the grader knows that this is f of x. Write it over here at the bottom, so that the grader knows that this is f of x and that it's equal to negative 3x, okay? So now we have to graph g of x, which is x squared plus 2, which is going to be a parabola, which looks different. So on my calculator, I can see that if I go into graph, I can see that this parabola passes through the point 2, 0, okay? So 2, 0, right here, and then it begins to stretch outwards in both of these directions. So those two directions are negative 1, it's at 3, at 1, it's at 3, so negative 1, it's at 3. Okay, now don't worry, those 2 points intersected, right? You saw how I put my red point above that green point. Keep that in mind because that's another part of this problem. But anyways, continuing to graph this, when x is 2 and negative 2, the y is equal to positive 6. So x is negative 2, so over here and over here, positive and negative 2, it's going to equal to 6. So if this is 3, then this is 4, 5, and 6. Okay, so again, over here, if this is 1, 2, 3, 4, 5, and 6. Oh, we intersected another time. Interesting. And I can't put any more points here, so what you'll do is you'll connect them with a smooth line. Do not connect these points with a rigid line that looks something like that. Make sure that there are no corners, that it's smooth, and again, draw arrows at the end of it, and then label this as g of x, which is equal to x squared plus 2, okay? So now, it asks us to state the values of x that satisfy f of x is equal to g of x. So when f of x is equal to g of x, that's when the lines intersect. And we saw here how the lines intersected at x equals negative 1 and at x equals negative 2. Okay? And you can verify that in the graph, in the table, right? Because at negative 1, they're both equal to 3, so they have the same y value and they're equal to each other, right? And at, what other point did we just say? At negative 2, we can see that they both equal to 6, right? So they're equal to each other at that point as well. All right, so again, intersection means that they're equal to each other at that point. Number 32 asks us, using the quadratic formula, solve 6x squared plus 2x minus 1 is equal to 0. So remember that the quadratic formula is negative b plus minus the square root of b squared minus 4ac over 2a. So whenever you have a trinomial, it's usually in the form of ax squared plus bx plus c, okay? So in this case, the number in front of the x squared is your a. So I know that my a is equal to 6 here. The number in front of your x that's not being squared is your b. So I know my b is 2 here. And finally, the number with no x is my c. So I know that my c here isn't 1, but it's actually negative 1. The sign matters, okay? So you take the negative with you when you define it, okay? So here, negative b, my b is 2. So I have negative 2 plus minus the square root of 2 squared minus 4 times a, which is 64. Sorry, whoa. 4 times a, so that's 4 times 6 times c, which is -1, okay? And that's all being divided by 2a, or 2 times 6, or 12, okay? So now let's evaluate whatever's going on inside of this radical. So I have 2 squared, which is actually 4, and I have that 4 minus 4 times 6 times -1. Now, whenever I write this out, I always like to put this 4ac inside of the parentheses. That way the signs don't confuse me. So I always want to multiply whatever's before the minus sign inside of a parentheses. It doesn't actually change the math. It just makes it a little bit clearer in my opinion. So I know that 4 times 6 is 24. That 24 times -1 is -24. And then I'm left with 4 minus -24, which is the square root of 28. Because 4 minus -24 is the same thing as saying 4 plus 24 or 28. So now this is equal to -2 plus minus the square root of 28 divided by 12. And this is where they try and trick you, because a lot of students will just say that this is the answer, but they're actually wrong. That's because you need to see whether or not the number inside of this radical contains perfect squares. Okay, so the way you do that is you list out the factors of 28. So 28 is equal to 28 times 1, 1 times 28, 7 times 4, and 4 times 7. Now, is any one of these numbers a perfect square? Oh, yes, 4 is. The square root of 4 is equal to 2. It's a perfect square. So what that means is you can separate and simplify radical 28. Remember that radical a times radical b is equal to radical a times b under the same hat. So I can rewrite radical 28 as radical 4 times radical 7, because under the same radical sign, it's just 4 times 7, and that equals 28. The issue is when I rewrite it like this, the square root of 4 is something we know. It's actually 2. And I'm left with 2 times radical 7. So radical 28 is the same thing as saying 2 times radical 7. And now I can write this over here. I have 2, or -2, plus minus 2 radical 7 over 12. And now that's my right answer. Wrong. Why? Because I can actually divide the top and the bottom by 2 to simplify this further. Right? Here I have -2. Here I have 2 times radical 7. Here I have 12. You can divide each one of these by 2. So -2 divided by 2 is -1. So that's -1 plus minus 2 divided by 2 is 1. So that's 1 plus minus radical 7 over 12 divided by 2 is 6. So I know that x has to equal to -1 plus minus 7, radical 7 over 6. You can write it as separate, like -1 plus radical 7 over 6 and -1 minus radical 7 over 6, but it doesn't matter. The Regents accepts this answer for full credit. Nice. Number 33 says the table below shows the price of a new cell phone and the length of time in months since its release. It wants us to state the linear regression equation for this set of data and to round all values to the nearest hundredth. So to do linear regression, you need to go into your calculator, press stat, and press edit. And what you're going to do here is you're going to make sure that wherever you see x, right, this column, this whole row is all of the x values. This whole row is all of the y values. You want to put all of your x values into list 1 or L1, okay? And you want to put all your y values into list 2 or L2. So I'm going to go ahead and do that. So now that I have my values in my table that match, all of my x's are together, all my y's are together, I can press stat again, and I can go into test. Okay, sorry, I can go into calc. Always calc. Then I can go down to where it says linreg. And guess what linreg stands for? It stands for linear regression, okay? And I press enter. And I can press calculate to get that y is equal to ax plus b, and that the calculator says that a is equal to -23.6667, 0.66 repeating, and that my b is equal to 1,216. Now, just copying this down gives you half the point. The other point out of the two, because this is a 2-point question. This is a 4-point question. Okay, so you've written this down so far. The way that you get full credit for this part is then by combining it. So plug in a and b into this y equals ax plus b form. So now you know that y is equal to -23.67. Why is it 0.7? Because we're rounding to the nearest hundredth, so there's a 6 here, so you have to round this 6 up. Okay, so that's -23.67x plus b, which is 1,216, and that's going to be the linear regression for this data, okay? The linear regression pretty much takes points of data and it turns it into an equation that gives you more points of data, okay? Now, the problem then wants you to state the correlation coefficient for this data to the nearest hundredth, okay? So naturally, a lot of you guys are going to see an r and our r square value pop up under there. The r value is your correlation coefficient, okay? But I don't have it on my calculator. That's because I have it turned off. So in the case that you're watching this video, you're following along at home, if you're taking the Regents with your own calculator, make sure that you have R showing. If you don't, this is how you make the R show. This is how you make the correlation coefficient appear, or turn that setting on. You go into second, 0, and you scroll all the way down until you're going to see diagnostic on, and you're going to press enter. And when it says done, go back into that menu. So stat, calc, linreg, and here you see R squared and you see R. So the R is going to be the correlation coefficient, not the R squared. So you can say that the R is equal to 0.97. Oh, sorry, negative 0.989. So negative 0.989. And because we're rounding it to the nearest hundredth, we have to change this 8 to a 9, okay? So the correlation coefficient is negative 0.99. So this next part then asks us what the correlation coefficient indicates about the linear fit of the data. So the correlation coefficient is just a rating that the calculator gives its equation, the equation that it came up with, to how accurately it would fit to a actual linear equation, right? So the correlation coefficient ranges anywhere from -1 all the way up to +1. So if there's a negative fit, for example, if your equation or your linear regression line, whatever the computer calculated, had a negative slope, that means that there's a linear fit to the data, but it's just negative, right? So our R value of negative 0.99 shows that even though our data is linear, it's a negative linear association, right? As the time since release in months increase, the dollars in price decreases, okay? But regardless, the closer you are to -1 or +1, the stronger the linear fit of your data, okay? And the closer you are to 0, the weaker that linear fit is. So when they ask us to state what the correlation coefficient indicates about the linear fit of the data, because negative 0.99 is so close to -1, we can just say that the correlation coefficient indicates a strong linear fit in our data, or it indicates a strong linear fit of our data, okay? So number 34 asks us to solve the following system of equations algebraically for values of y and x. Okay, and that's important. So when we're solving a system of equations, we just want to plug in values. So I notice here that I have y minus 2x is equal to -6, and that this is in terms of y. So if I can figure out what y is, I can just plug it in over here and then solve. So over here, I know that y minus 2x is equal to -6. So what I can do is I can just add 2x on both sides, and I get that y is equal to -6 plus 2x. Well, now that I know what y is, can't I just plug it into this top equation over here? And the answer is yes, I can, right? So now I have -6 plus 2x is equal to x squared plus 9x plus 4. Okay? So now I just solve for x, right? So I can add 6 on both sides, and I get that 2x is equal to x squared plus 9x plus 10. And I can subtract 2x on both sides to make this equal to 0. You always want to make it equal to 0. So now I have 0 is equal to x squared plus 7x plus 10. And now what I can do is I can try and factor this out. So I'm looking for two values that multiply into positive 10, but add into positive 7. And those two numbers are 5 and 2. 5 plus 2 is 7, and 5 times 2 is 10. So now I have my two numbers that I'm going to split the 7x into. So I can say that 0 is equal to x squared plus 5x plus 2x plus 10. So I split the 7 into these two numbers so that I can factor it out. So now I can take out the x, and I'm left with x plus 5. Here I can factor out a 2, I'm left with x plus 5 again. I can combine both of these x plus 5s in one parentheses down here, x plus 5, and I can combine these two into another one, x plus 2. So now I know that 0 is equal to x plus 2 times x plus 5. To solve for x, I need to set each one of these parentheses individually equal to 0. So here I have x plus 2 is equal to 0, and here I have x plus 5 is equal to 0. Because remember, multiplying anything by 0 makes everything 0. So if, for example, this value, x has to equal to -2, and this one, x has to equal to -5, right? These are the zeros of the function, essentially. So if I were to plug in -2 plus 2 is 0, and it doesn't matter if it doesn't make this parentheses equal to 0, because if you're multiplying anything by 0, it'll all be equal to 0. So anyways, you just set both of them equal to 0. You get that x is equal to -2 and that x is equal to -5. But remember, we want to solve for all values of x and y. So because we're solving for all values of x and y, we now need to plug in those values of x to find y. So I already said that y was equal to -6 plus 2x. So my first point is -2. So if I plugged in -2 here, y is equal to -6 plus 2 times negative 2. 2 times negative 2 is negative 4. Negative 6 plus negative 4 is negative 10. So my first point is x equals negative 2, y equals negative 10. And my second point here with this minus 5, well, if y is equal to negative 6 plus 2 times minus 5, 2 times minus 5 is negative 10, and negative 6 plus negative 10 is negative 16. So here I have x equals negative 5, y is equal to negative 16. And that's going to be the correct answers over here, okay? So now we're moving on to part 4. The last question says that Sarah earns $6 per hour babysitting and $12 per hour tutoring. Her goal is to earn at least, key word here, at least $120 per week. Sarah is allowed to work a maximum of 14 hours per week doing both jobs. If X represents the number of hours Sarah babysits and Y represents the number of hours that she tutors, write a system of inequalities that can model the situation. So notice here, they're not asking for a system of equations, but a system of inequalities. That means we're going to be dealing with greater than signs, less than signs, greater than equal to signs, greater than less than signs, stuff like that. So we know that Y represents the number of hours that she tutors, okay? And we know that she earns $12 per hour tutoring. So the amount of money that she earns from tutoring is just $12, her hourly rate, times Y, which is the number of hours that she works. And if she adds that to $6, which is the amount of money she earns per hour babysitting, and she multiplies that by X, which is the number of hours that she babysits for, that'll give you the total amount of money that she earns from babysitting. Now her goal is to earn at least $120. So if you're making at least means at the lowest. The lowest amount of money that you want to make is $120. So that means that 12y plus 6x has to be greater than or equal to 120. Now, why or equal to? At least means that she's okay. At least just means at the minimum. At the smallest allowable value, she can earn $120. So yes, 12y plus 6x could equal to 120, but she wants to make more than that, which is why it's greater than or equal to. All right? Then, if y is the number of hours that she babysits, and x is the number of, if y is the number of hours that she tutors, and x is the number of hours that she babysits, we know that she can work a maximum of 14 hours per week. So if you're working a maximum of 14 hours per week, that means that you can't go above 14. So you can work up to 14 hours, but you cannot go above it. So that means that x plus y has to be less than 14 or equal to 14, less than or equal to. Why? Because again, a maximum of 14 means that the max is 14. You cannot go beyond 14. You can stay at 14, you can't go beyond it. So that is our system of inequalities here. Then they want us to, on the set of axes below, graph the system of inequalities that we wrote, okay? So it's gonna be pretty easy, right? We just have to graph these equations out. Notice here that whenever you're graphing inequalities and you have a greater than or equal to or a less than or equal to sign, you're gonna write a solid line, okay? And whenever you have a less than sign or a greater than sign, you're going to draw a dashed line. So we're going to have two solid lines here because we have, either way, we have a greater than or equal to and a less than or equal to sign. Now, when the sign faces the x, right? Or I guess it doesn't really matter in this case because we have x and y on the same side. So anyways, what you need to do here is you need to rewrite these in terms of y equals mx plus b form in order to figure out how to graph them. So I'm going to graph this first equation first. If I have y plus x is less than or equal to 14, remember y equals mx plus b form, right? Slope-intercept form, the slope plus the y-intercept, okay? So if I subtract x from both sides, I get that y is less than or equal to negative x plus 14, okay? What this tells me is that the y-intercept is 14. So if this is the y-axis, the first point has to be at 14, okay? Then we're decreasing by 1. Now, if we just look at what happens over here, we know that at this axis that x is equal to 0. And at this axis right here, we know that y is equal to 0. So when y is equal to 0, we know that x has to equal to 14, right? Because the only way to make negative x plus 14 equal to 0 is by making it 14. So in other words, like you can go and you can plot out every single point using the slope, right? Remember, the slope is -1 because there's -1 in front of x, and -1/1, your rise is -1, so you're going down by 1 and you're going to the right by 1. So if you really wanted to connect all the points, it would look something like this. But as long as you have 2 points, you can draw a straight line through them in this case, and that would be your complete graph. So this is my complete graph for, and I'll have to label it, y plus x is less than or equal to 14. Okay, now we have to move on to this graph over here, and it becomes a little bit more tricky. So here I have 12y plus 6x is greater than or equal to 120. So again, I want 12 on its own, so I can subtract 6x from both sides, and I get that 12y has to be greater than or equal to negative 6x plus 120. Now I have to divide everything by 12, okay? So now I have y is greater than or equal to negative 6x plus 10. Or sorry, y is greater than or equal to negative 6x divided by 12, which is negative 1/2 x plus 10, okay? And before I go ahead and graph this, I just want to make a point that whenever the inequality sign faces towards the x, you're going to have to shade down. So because we're dealing with inequalities, we're going to have to do quite some shading here. So you just draw a line facing downwards. You're going to the bottom of the page because the inequality sign faces towards the x. If it faced towards the y, then you would have to shade towards the top of the page, okay? So regardless, I now have this equation written out. I know that my y-intercept is 10, so the first point that happens here on this graph is 10. Now I can do the same trick, right? I know that on the y-axis, the x is equal to 0, right? Now on the x-axis, the y is equal to 0. So if I set y equal to 0, y has to be greater than or equal to negative 1 over 2x plus 10. So that means that x has to equal to 20 in this case, because negative 1/2 times 20 is negative 10, and negative 10 plus 10 is 0, right? Which is what we set y equal to. So the final point here is going to be all the way over here. But again, you can do negative 1 over 2, right? Your rise is negative 1, so you're going down by 1, and you're going to the right by 2, like this, and like this, and like this, all the way until you're going to reach that 20, right? So again, just two different ways of doing it. Either way, you're going to have to connect this with a straight line like so. And then because the inequality sign is facing towards the y, you're going to actually have to shade up towards the page, okay? So you're shading above like so, okay? And remember to mark what line this is. So this is y, 12y plus 6x is greater than or equal to 120, okay? Then finally, to get the last points, you need to indicate where the solution is. And the solution is always where the two lines not where the two lines intersect, but where the shaded regions intersect. So we can see that there's overlap over here, right? The purple goes up and the green goes down over here. So this is our solution, and you just mark it by a big S over here. Okay, so essentially, any point within this region will satisfy both of these inequalities, okay? And that's exactly what the last part of 35 asks us. It says, state a combination of hours babysitting and tutoring that would satisfy this situation. Justify your answer. So any combination can be found here. So for example, this point right here of 1 hour babysitting and 11 hours tutoring works. So you can say, 1 hour of 1 hour of babysitting and 11 hours of tutoring satisfy the situation because that point 1, 11 falls within the solution zone for the system of inequalities. Okay, so you could have also just plugged in the point 1, 11 into these two equations to show that it made both of them true, but regardless, that's how you get full credit on this question, and that is the last question in this section. So that's all of these short response questions reviewed in one video. If you have any questions, feel free to let me know in the comments down below. Again, if you wanted to see the multiple choice section of this exam reviewed, I already uploaded that video. It's in the description. Hope you guys learned something, and I hope you have a nice day.